I'll start the presentation with a magic trick. I'll unlock my computer by pressing enter. Ooh, sneak peek of what you're about to see. All right, we are good to go. So, title of talk today, Decentralized Authentication is our only hope. I truly believe this as a society, that if we keep going the path we're going with certificate authorities and kind of centralized trust models, that eventually tragedy is going to happen. So the talk today, I'm going to go through my entire career of where I came to this conclusion and what I'm doing about it. So the problem that first hit me in the face, I guess in 2008 when I was in grad school, and like, hey, what do I want to research? What's a good thing to do if I'm going to change the world, is that authentication sucks. Passwords were hell. Everyone was getting hacked. Like I started my career as a hacker like a teenager, and it was just like you win all the time. And I just learned from this like addiction book I'm reading that if you win all the time, it actually loses its like excitement. So I think maybe that's part of the reason I got into this, that like you actually need to almost win sometimes. So agenda for today, we're going to go through a little bit of history of authentication. I won't bore you too much, but I want to at least like kind of show you where we started and where we're at. We'll do decentralized authentication, single device authentication, which is what I studied in grad school and most of my career. And then we'll do decentralized recovery, a really hard problem. I'll tell you about Allthenticate, and then ultimately I'm going to tell you how we're going to save the world. So I'm Chad. My career started back in 2000, I guess. I was a site tech and a pre-check founder in the scene, if anyone is familiar with like the old IRC wares scene. That's how I cut my teeth in computer science. The only reason I thought these things were valuable was to steal movies and games. I don't know if my opinion on that has changed much, but I do find more value in them than I once did. I got into playing CTFs. I started to get a PhD and I dropped out, and then I went back and actually got a PhD. So if you really want to make me feel weird, you can call me Dr. Spensky. Nobody does, but it's legally allowed. I have the paperwork. And then I worked at MIT Lincoln Laboratory, where I was actually a professional hacker for the DoD. We did offensive research, in particular for DoD caliber problems. And that's where they kind of like got in my brain thinking like bigger problems, like, okay, national security problems. If you were going to destroy the United States, how would you do it? And then how would you defend it? So this is where a lot of this decentralized thought really started to like hit home with me. I'm like, yeah, we could crumple our entire society. So I am qualified to give this talk. As Razib was alluding to, I've released a lot of open source tools. If you want to hack smart cards, you want to fuzz NFC, you want to make glitch-resistant software, you want embedded systems that even if you root the system, you cannot turn GPIO pins on and off. We also discovered a vulnerability on every Android phone on Earth where you could pass a pointer into trust zone and read and write all of kernel memory. I've published a couple papers and like peer-reviewed conferences, one on privacy on mobile devices, access control misconfigurations. We also fuzzed all the trusted execution environment apps on modern Android phones, and we filed a couple patents along the way because we decided to go commercialize this stuff. So let's get to authentication. The early days, the only reason you needed a password is because you had these humongous clunky computers and you didn't want just anybody having access to them. So really quick fix, hey, we'll put a password, only people with the password can log in. So putting that in perspective, this was 1961. First password was invented. Then the internet started to emerge in the 80s. Then we had the World Wide Web. Then we had personal computers. Google came out around 1998. The iPhone was released 2007. 2010, IoT devices take over the world. Today, we're still standing here with the thing that was invented in 1961 still as the #1 security feature that people are using. Right? We're starting to get better things, but this is kind of, to put in perspective, the fact the password has survived is shocking. There's a lot of really cool research. There's, a lot of really good like academic studies on why it survived. So why they suck, we'll just highlight it really quick. The idea of the symmetric secret is the problem with passwords. It's nothing inherently wrong with the scheme, the security. Forget about all the hashing and salting and database leaks, irrelevant. The real problem is that you have a secret and the server has a secret, and that secret must be known by both parties, and you must pass that secret around. I must enter that secret, in this case, with my meat mitts here, into my computer. So that secret is going to leave my brain and it's going to enter, like the secret is now out in the world in another medium. That's the real problem with passwords. So you can either hack the brain, you can observe people typing it, you can hack the computer that it was entered into, you could compromise the encryption going through, you could compromise it. Like there's so many places where this secret is just being spread around. And what we've been doing is just band-aiding these symptoms, right? We're just throwing band-aids on there to, okay, we're gonna patch the, when you type it in, so we can have encrypted keyboards and stuff like that, right? We can patch that you don't have to store the secret on the database. We're gonna put it in a hash thing. We're gonna salt the hash to make brute force harder. Irrelevant though. That's not the core problem. The core problem is you have a shared secret. So passwords, MFA, 2FA, all of that is dead, in my opinion. So if video killed the radio star, phishing killed the password star. Because once phishing got to the point where it is now, you throw any security you want at it, and it is irrelevant because I'm going to have the person just literally type it in to me. So whatever you do doesn't matter because I'm just going to get them to blurt the whole secret out. You can be 50 characters, uppercase, lowercase, whatever. I trick the human, boom, secret leaves their brain. Now it's in my database. So just highlight really quickly how easy this is. You can go to this Evil Engine X GitHub repo. You could pull that repo, get yourself like a $20 DigitalOcean account, and set up like a really advanced phishing campaign on any site on Earth. And it will even phish your 2FA codes and things like that. And the problem there, which you can see depicted in this diagram, is that, okay, I'm going to enter the password in this computer. It goes to this website. It checks the password. It sends me a code. And then I enter that code into the same vulnerable place that I just entered the vulnerable password. Like once your UI is going through a web browser, the fact that the page changed doesn't make that less vulnerable. That's still where the attacker is going to target. So if you're right there where Evil Engine X sits, you can still use a password, OTP code, whatever you have them type in. They can take a picture of themselves. It doesn't matter because you're just going to steal all their credentials. And in the limit with that, you can actually not even sit there, but you could run a VM in the middle where you're interacting with the actual website, but on my VM. So then when you log in, I'm logged in and you're not logged in. So the other one is that MFA fatigue. So what will happen now if you have like Duo-like apps? You could be anywhere in the world. You could be in Aruba. Someone phished your username and password, or someone logged in, and you get a prompt. Because there's no proximity binding there, they can just keep doing that until you eventually say yes. I think this is how a lot of Twitter accounts and stuff got hacked. I think Barack Obama's or someone, one of like the really high-profile accounts, got hacked, something like this. So we can do better, right? There's a lot of really smart computer scientists on Earth, and we shouldn't be taking these haphazard, half-assed solutions in stride. So in 1983, something really cool happened in the world of cryptography. We started using asymmetric secrets. So this is Rivest, Shamir, and Adelman, who created RSA, one of the most popular, widely used asymmetric schemes on Earth. And the novelty here, which was really cool, is that your private key never leaves. So the problem with passwords, we're passing these secrets all around. We have to enter them in. But in this case, Alice, who looks really intense, so this is my first time using AI-generated images, so this talk is just going to be absolutely lit because the imagery is great. So Alice will never give up her private key, but she can give Bob her public key. And then once they do that, you can use the private key for decryption. So if Bob wants to send me something securely, he can encrypt it with my public key. I can decrypt it. And for the point of authentication, with my private key, I can sign things to prove that I am me. And you can verify them with my public key. This was a game changer. This enabled e-commerce. Without asymmetric encryption, you could still have e-commerce, but it would be far, far more Wild Westy, and I don't think I would be participating. So finally, we have this public key panacea. Secrets aren't being spread all over the internet. Ta-da, we did it. As a society, we've advanced. This was in 1983, mind you. Nothing has seemingly changed in our worlds, unfortunately. There are systems that use asymmetric keys today. So these are like the early adopting systems. So smart cards use asymmetric keys, all the USB hardware tokens, TLS client certs. This has existed forever in the TLS spec. I don't know why it was not more widely adopted. Like I know at MIT, we did use this. You'd put your private key on your laptop, and you'd use that to log in and set passwords, SSH keys, and most recently, FIDO passkeys. These are TSL client-side cert round 2, I guess, if you want to think of it that way. But there be dragons with asymmetric keys, right? The early adoption of these, the usability was terrible. The scalability was terrible, and recovery was non-existent, right? I give you a smart card. That smart card would log you into one thing, for example. You can actually install applets on the smart card. The most popular operating system on Earth is Java OS that runs on every SIM card and every smart card on Earth. They will never let you run applets because the internal segregation is terrible, so everyone will lock it down. That's why you have multiple credit cards. In theory, you could have all of your credit cards on one physical card, but there's like political and somewhat security reasons they won't do that. So if we're really going to go the smart card route, you'd end up having a smart card for every single website on Earth, and it'd get crazy. And then when you lose your credit card, it's a nightmare, right? Or you lose your YubiKey, the recovery has always been this kind of looming problem of like, what do we do? And since they're dragons, I don't know if it's scalability or scaleability, but either way, it's relevant. So it all comes down to trust, right? And this is what we're talking about, like centralized versus decentralized trust. So we decided collectively, not me included in this conversation, but society has decided that we're going to do a centralized certificate authority trust model. So back in the day, there were only a handful. Everyone decided that was a bad idea. We don't want all of the trust with 5 people, so we need more CAs. And now we have a lot of CAs. So when you go in your browser, if you're using Chrome, you have 134 root CAs, 168. These change, so these are rough numbers, but at the time I made the slides, they were accurate. In Microsoft, you have 283 root CAs. But why do you trust them? Just because the software vendor decided to trust them? But you don't know anything about these CAs. I doubt anybody could list off all 134 that they trust in their browser. And how bad could it be, right? So I really like this quote. If you trust a person, or in this case a CA, you either have a friend or you have a life lesson. And how do you know if they're compromised? You don't, right? If the private key is in someone else's possession, you have no clue. So the hard questions that are unanswerable, how many CAs are currently compromised? How would you know? And what would you do if you knew? Like, what could you possibly do? If you knew that VeriSign right now was leaked, how do we even recover from that? Because you don't know how long they've been leaked. You don't know how much damage has been done. And Carl Sagan said the absence of evidence is not evidence of absence. So just because we don't know doesn't mean it's not happening. And in fact, it did happen. Did you know Tar actually got compromised back in 2011? So this was one of the root signing CAs. And they were man-in-the-middling a lot of Iranians. So to this day, we don't know how much damage or lives were lost or whatever, but like this is not a hypothetical doomsday scenario. It actually happened, and I was working at Lincoln Laboratory when this went down, so it was like, you know, from a government perspective, this was a real eye-opener that we can't keep doing this. So Kim Kardashian tried to break the internet with some scandalous photos, but if you compromise a CA, and you have a way to hijack DNS, you just have some router exploit that works on, you know, most TP-Link routers, it's game over. You do whatever you want. You point anyone to any website, phishing, whatever, it's done. Like, you win, internet is yours, congratulations. Sidebar, we now place so much trust on DNS. The point of DNS was supposed to be to help humans map names to octets, right? We're not good at memorizing 8-bit numbers that are with dots in between, but we're really good at memorizing names like Allthenticate.com, But because of the way we've kind of adopted this whole architecture, even in FUTO, which is a new scheme, it is tied to the DNS entry. Your private key and your public key are going to be bound by this DNS entry. And that DNSSEC is not going to happen. I think at this point we've all given up on it, but it's just strange how the trust models, right? The creators of DNS never said this to me, the root of trust on the internet, but now it is. And somehow we just accept that. So hopefully everyone's convinced at this point, centralization is not it. We're not going to get there doing this. So let's talk about how we can decentralize authentication in particular in this. I'm not going to go into anything else other than authentication. And just to summarize the difference, so this snow leopard here is a centralized organism, right? It is one thing. If you kill that, the snow leopard is dead. Versus a swarm of bees that have this insane resiliency. If you've ever gone head-to-head with a swarm of bees, no matter how many bees you kill, it doesn't matter because the swarm will survive, right? And that kind of mentality as a digital species is really powerful. That if we have this CA that when you chop the head off, all of our trust falls over, versus we're all a swarm of bees out there, and a couple might get hacked, a couple might get compromised, lose their phones, But as long as the majority of the swarm is alive, we can survive online. Distributed does not equal decentralized. I actually have to like go back to this many times myself and be like, okay, what's the difference again? So distributed system is when you take a single task and you break it over many computers, right? So, okay, I'm gonna compile a program that's one task and I'm gonna do it over multiple processes. So I'm distributing that load or I'm gonna put it in a Hadoop cluster. A decentralized system is the fact that every single entity is independent. So it's not, there aren't one global thing that's dictating the tasks out to worker bees. It's everybody is exactly the same and has the same capabilities to operate in this independent, decentralized nature. So the original internet, in my opinion, was decentralized. So you had your Usenet, your BBSs, your IRC chats, like all of this, like on IRC, you could have multiple servers that are still the same server, but if one server drops, it's okay, you could reconnect to the next server and still be on the same entity. Like the original thoughts of the internet were mostly decentralized thoughts. Most of the people on the early internet saw this as a way that, okay, there's more like freedom to the people, this will democratize technology, and it all ended up getting lumped up in the end. So if we look at authentication protocols on the internet, so we'll say 1983, the internet began, we actually had X509 certs come out pretty soon after that, so that's what you're using for TLS and things today. Those are gonna be your X509 certs. PGP came out in 1991, which was a fully decentralized model, and we'll get to that in a second. We got TLS, so we finally got HTTPS. And then SAML came out in 2002, which let us do single sign-on, which in my opinion, actually put us back in the wrong direction. Things were going well, so now what SAML does is it aggregates all of your sign-ons through one identity provider. So when you see login with Google, that's actually OpenID Connect, but it's the same kind of thought process. And then we had OpenID Connect and FIDO U2F. And then FIDO was developed in 2015. It still hasn't quite happened yet, but you can use a FIDO passkey to log into things, and I will show you how to do that in the demo. And then we have verifiables, credentials, and WebAuthn. So verifiable credentials really are looking at like truly being decentralized. Can I have my driver's license on my phone? Can I prove to you that I live in Texas, but I don't give you my age or eye color? So that one's actually quite interesting. And here we are today. We're still using passwords, but there's been a lot of interesting things that have been developed. And I really think that tomorrow we will have decentralized and self-sovereign identity. I think we can get there, but there's still tons of hard work in the mix. So I want to go back to PGP. This has kind of been my North Star research-wise. I've actually since become friends with John Callis and Phil Zimmerman, who created PGP, and kind of asked them what went wrong, because this seemed like a really, really good idea, and why did it never catch on? So the idea with PGP was really email encryption, but they had a really interesting trust model around that. So public keys would be bound to emails, and private keys were used for signing and encryption. The one small problem, which turned out to be the problem, was there was a seminal paper about it called Why Johnny Can't Encrypt, a usability evaluation of PGP. Phil seems to agree 100% that the cognitive burden, as he phrases it, with PGP was far too high. It was too complicated to use. So if this were a PGP key signing party, we would all stand up one at a time and read out our hash of our public key, and everyone else would verify that and then sign our key in return, right? That is a lot. That's a lot to ask of people, and it did not scale well, the web of trust, and how to introduce a new trusted key into the system. The most interesting thing they did was called the web of trust. So rather than having all of these CAs that you trust, everybody can trust whomever they want, and they had a really intricate web. So what would happen here? Say I go to google.com, and it's my first time ever visiting google.com. I don't know google.com, but my web actually knows google.com, and because people I trust google.com, I now know I can trust google.com. And you can kind of see the idea here that you have both direct trust, so like Ava is friends with Manuel, but you also have indirect trust. So Ingo is friends with Ava, trusts Ava, but doesn't trust Manuel, but has an indirect trust relationship because you trust someone who trusts them. And you could build this really strong, resilient kind of beehive mentality of trust relationships. So the ideas were fascinating. As an academic, I was so hooked on this. Still, the fact that I've even talked to Phil Zimmerman once on the phone, like, I get like giddy. I'm like, I'm a huge fan of yours. Like, because it's such a cool idea, and it really could solve a lot of the problems and compromises that we see today. So this is what authentication looks like today. This is a typical corporate login, or when you click login with anything, right? Login with Google, login with Facebook. You're gonna type in your username, your password, your OTP code. It's gonna, I'll just walk it through. Oh wait, you can't hear me. I'll point and walk it through. So you type in your username and password to the website, OTP codes, whatever. They're gonna then send you a redirect. Your redirect then goes out to a third-party identity provider. So this would be, Google, Allthenticate, Okta, Ping, whatever you're using. That third-party identity provider might send you another code. You type that into them. Ultimately, they make the yes/no decision. They pass a token back to your web browser. Your web browser then redirects back and passes that token. So there's a lot of HTTP redirects and things happening in this process. The problem is it's just vulnerabilities everywhere, right? Like we still have the observation vulnerability. If I'm key logging or anything on the computer you're using, I could have malware on the computer that can intercept everything in the middle. I can phish you. I can man in the middle your IDP, not even necessarily the thing you're logging into, but if it redirects you to me, I win as well. I could compromise the IDP, which has nothing to do with the service you're logging into, which is also interesting. So say I make the most secure website on earth, but you click login with Google and Google gets popped. Now I get popped. And then there's session hijacking, which is a whole nother issue. So what happens now when you log in, I hand you a random string, and as long as you present that string, you're good to go. So you can literally take that string. It used to be much easier. I could take that string, put it on my laptop, go to Houston and log in as you. They now will kind of tie them to IPs and things. Very circumventable though. The idea that you being logged into your bank account is a text string stored in a cookie session header in your HTTP request in 2025 to me is still like not okay, right? So it's like, okay, getting in the door is so super, super hard. But once you get in, here's a magic token. Don't lose that token because then you're screwed. It's like, then what was the point of all the other stuff, right? And hackers are only going to go wherever it's easiest. So right now, phishing is really easy. Phishing becomes hard. You're just going to steal. You're just going to session hijack. It's a little bit harder, right? But it's not impossible. So, in my opinion, I think we're one IDP hack away from absolute catastrophe. I mean, Okta was very close, like this close to actually getting a fully compromised. So I think it was just their customer service portal. So Okta is the biggest IDP in the US. I don't know about the world. So every corporate login that you do, you click, it redirects you to Okta and will redirect you back. If the attackers would have had one more pivot and actually got what they wanted, they could have logged into pretty much any corporation in the US and done whatever they wanted as whomever they wanted. So this is actually the world record for Jenga stacking. He did 1,843 blocks. And my point is this is what our security infrastructure on the internet looks like today. These are all of the websites that you can sign up with Dropbox, Facebook, Google, whatever. If any one of those IDPs falls, they're that one little block at the bottom, and the security for every company that uses them is gone as well. So let's jump into some research. So as a wide-eyed, really excited young researcher that was like, I'm going to change the world, I got obsessed with the idea called single device authentication. I was like, we could use one device for everything. To put this in context, my advisor came from Carnegie Mellon, and they had Nokia phones that did proof-carrying authentication and scanned QR codes to open doors and log into computers, but that was never really finished. So I'm like, Mike, this is it. Like, this is grad school. This is why I came here. This is amazing. We're going to use phones. We're going to log into everything. So the idea is you have one phone, you put all your keys on the phone, and use that phone for everything. The general goals, kind of the opposite of everything we've just seen that's actually happening. So we're going to use secure private keys. We're going to use asymmetric keys. There's going to be a hardware token. So there's going to be a something you have attached to this, not just a something you know. We could use physically unclonable functions. We can use secure elements. We can use trust zone. There's a lot of like really beautiful things at the hardware level that give you security that's just unprecedented. We have to decentralize trust to mitigate these doomsday scenarios, eliminate credential theft, and eliminate session hijacking. These were like our high-level research goals to save the world. Fortunately for enough, there is actually a framework for getting rid of the password. So John Bonet and a bunch of other researchers, they have this paper they published, The Quest to Replace the Password. So they came up with this table. So this table was the first thing we did in our research, was to figure out, one, is it possible to get a perfect score? Like, if this is truly what they think, and we kind of read a ton of papers, this framework was very nice. Like, one, can we get a perfect score? You can see our research on the right that we called single device authentication. In fact, we were able to get a perfect score in security, assurance, features, and usability. So the middle circle means that it is partially done. Since then, the nothing to carry, we count it as partially because you already carry your phone. You could embed this in your hand and stuff if you go kind of crazy with it. But once we answered this question and realized we could get a perfect score, we were motivated to actually build it. We actually built prototypes with the biggest emphasis on usability. Like, if this is not the most usable system on earth, we're going to go the ways of PGP. So we ultimately did a bunch of user studies. Bluetooth Low Energy seemed like the best use case. We tried USB, we tried NFC tap, tried a bunch of different things. We haven't implemented this yet, but in the limit, you could do machine learning to auto-approve requests as well. So I wake up in the same house every day, I go to the same gym, I drive the same GPS route, I show up at the same office with the same RF signals around me, and I log in, roughly between 7:30 and 8 a.m. every day. So if that pattern exists and my authentication is 99.9% sure it's Chad, bang, you could actually go right in without anything, without compromising security. So this is the stuff we were looking at in our research. This was like 15 years ago, and I've not stopped. I've not lifted my foot off the gas pedal since we got this score. Since we realized this was possible and flew in ARM engineers and explored, trust zone and all that stuff. We got to do it. We got to at least try it, put it out there in the world and see what happens. So this is what authentication looks like with SDA. So I showed you before that you have all these IDPs and everything. The website could easily install their own plugin to say hey, whatever type of credential you want, we accept, a FIDO passkey, whatever. You're going to type in your username, and that's it. The website will then send a challenge that's encrypted that will go through your computer to the phone that only TrustZone can decrypt, that then, if needed, will present a challenge to the screen on your phone. And then and only then does your brain need to get involved, which would typically be a single pin for everything on Earth, or a biometric. And then it sends an encrypted response, again, from TrustZone. So the OS, like iOS, Android, cannot read this. Everything on the computer cannot read this. You don't even need TLS, actually. You could remove TLS, and you would be fine. My goal was I wanted to do banking in a hotel lobby. I was like, if I could go to a hotel lobby and do banking securely, I'm confident. The only attacks that we left open was the physical compromising of a phone. So you'd have to come and physically get it and attack the secure element. There are some pretty insane software chains that could compromise the hardware. I've been involved in some of those in my research. But realistically, you're down to physically stealing phones and compromising service providers. The problem with all of this would always come up, what if I lose my phone? That was the single greatest question we ever got, and we're like, I know there's research answers to this, but that's kind of like saying, the difference between theory and practice is everything. We're theoretically we could do it, right? So we had this idea forever. This is actually why we had a party here last week, 2 weeks ago, because we actually implemented this. It's in our product. To do fully decentralized recovery. So the way it's done today, if you use Google and you put a passkey or your passwords, they're going to back them up in their cloud, right? And you can do some end-to-end encrypted cool stuff, but it's not truly decentralized. Because if their cloud goes down and you go get a new phone and you can't talk to their cloud, it's kind of game over. And it's not stored with people you trust. So I call this human-centric recovery. So what's going to happen here is that Alice is going to have all of her private keys stored in her phone, and these are Alice's most trusted friends. I'm the cute girl second next to Carol, the buff dude. So AI has its own interpretations of what a Chad is, and that's what Chad is to Gemini. So she's going to encrypt all of her keys with an AES key, right? She'll take all the key stores, she'll use an AES key, she'll encrypt them, and now you have an encrypted blob. And then she's going to take a Shamir secret sharing scheme, and she's going to break those secrets into 5 shares. If you're not familiar with Shamir's secret sharing, he's the S in RSA. The coolest thing about this scheme is it's not a cryptographic scheme. It's not based on hardness assumptions. It's actually mathematically sound. So given infinite compute resources on Earth and 1 share, you can do absolutely nothing with it. So then what happens once she has these 5 shares, you can probably anticipate where this is going. She's going to give that encrypted blob and one of those shares each to her friends. And these shares will be encrypted with her friends' public keys. So she encrypts it with the public key, sends it to them, and now her backup is fully decentralized. There is no cloud needed with this. There is no service provider needed with this. As long as those phones can communicate and she ever needs to recover, 3 of her 5 friends can fully recover all of her secrets. So to recover your keys, somebody must first vouch. So say I get a new phone, it's going to show me an ID on my phone, and I just need to get in touch with one of my friends and have them vouch. Hey, this is actually Chad that's trying to launch this rescue mission, as we call it. So in this case, Dan, I read Dan the number, and he reads it out, 082379. He types it in, boom, rescue mission starts. So now, I guess that's not a transparent background, I just found that out. But now what's going to happen is that all her friends, their phones, now that no rescue mission is happening, are actually going to send a challenge to Alice's phone in the background, and then she will have to get on a video chat with them and answer that challenge. So they can challenge response any way you want, but first thing you'll get is a video. Hey, it's Chad, I did lose my phone, banana popsicle monkey, right? And then if they have any doubt, they can call me, they can do whatever out of band to verify it's me. 3 out of 5 shares. After they verify the video, 3 out of 5 shares, and all your keys are restored. And you didn't have to worry about having a safe at your house for a YubiKey. You didn't have to trust an iCloud provider. You know where your keys are at all times. They're in the pockets of the people you trust the most. So with all of this research kind of culminating, I had a choice to make 5 years ago to become a professor and stay in academia, just like shaking a stick at people, or actually literally put my money where my mouth is and go try to decentralize authentication. So started Authenticate 5 years ago with Rita, who's here 4 rows back. The technical goals that we wanted to accomplish here were that keys are stored on the end user's phones at all times. The keys never leave the phone. In our minds, the second the key leaves the phone, all security goes out the window. Because once it can be copied anywhere, you have no clue who has possession of it. As long as it's bound to the hardware, I know my keys are right here. My SSH key, my X519 certs, I know everything is physically here. Hardware enforced security whenever possible. So my PhD was in analyzing and securing embedded systems, so really, really low-level hardware security mechanisms like tagged memory architectures and things like that. Fully decentralized with no single point of failure and no single point of trust. And then this was kind of the biggest one that smart cards failed, that secrets could only be entered into trusted hardware. So you're still going to need a PIN or a biometric. At the end of the day, you're going to want something to protect those keys. With smart cards, you would you'd put your smart card into your computer, and then this very janky JavaScript-looking pop-up would pop up and ask you for your PIN. And at that point, you kind of lost control of this trust chain. So that was one of the things that we really emphasized, that you have to have secure input and output with the hardware device that holds the keys. And then the ability to authenticate all of the things, hence our name. We're like, we don't want this to just be like a web login. For it to really be valuable, I really do want like my car, my house, my Bitcoin wallets, my everything. Like, let's put them all in one piece of secure hardware that I know is like in hardware. So our just cause is that I think everyone deserves to be secure on the internet. I truly believe this. Like, there's no reason because my grandma sucks at technology that she deserves to have her bank account emptied. Like, it's not an adversarial game. As a CTF player, when you walk in the ring with me, now it's game on. We've agreed to a duel, right? Or in the case of like, if my neighbor sends a deauth packet at me, I think that's a declaration of war and it's on. But my grandma's not out there deauthing people. So our mission is to create secure cybersecurity products that are fun to use, and we want to respect user privacy and their basic right to use computers securely. So the cool thing with this key architecture is you can generate as many private keys as you want. So when you go to Facebook, you generate a new private key. You go to Instagram, you generate a new private key. And there's no possible way to link those. They're just random numbers. So we filed a patent at 2015, started the company in 2020, and we moved to Texas in 2022. So all of these products exist today. You can have your app, you can unlock doors, Windows computers, Linux computers, Apple computers. That was the sneak peek I showed you. One of the coolest features you get from this, in my opinion, is that our security architecture, my phone, it's decentralized, it's talking to my computer over Bluetooth. When my computer goes to a website to log in, that website will send the challenge to my computer, encrypted, that is then forwarded to my phone, that then responds and goes back. So I can actually have a security key log me in securely with a physical hardware token with my phone in my pocket. I don't have to get it out, I don't have to do anything. SSH key being on my phone, that was like a Saturday where I just came in and like, I need this, I'm sick of this IDRSA file, and I don't want my SSH key in the cloud. It was super easy for us to add that on because we're already secure key storage. So it's a Bluetooth-based app, so we actually put FUTO passkeys in there. So if you don't want to use iCloud and Google Drive, which I don't, you can actually put them in there and they'll be backed up physically on your phone and with your friends. Your SSH key, we added OTP codes because some people live in the past and we need to I have tons of websites that will still force me to use OTP codes. And I'm like, I don't want the Google Authenticator app on my phone, so we put them in our app. There's a self-signed X509 cert. That's how we do all the decentralized authentication, and we do rescue missions. I don't know if we'll stick with X509 certs. I haven't seen a compelling reason yet to switch it to verifiable credentials or like a PGP key, since all we're really doing is the authentication portion. But we can change that in the future if needed. Works on Windows, Linux, and Mac. Works seamlessly with your SSH client. System-wide password lists. There's FIDO support where you're doing like BLE over USB effectively. We built our own hardware because we said we wanted to authenticate all the things. And one of the fun projects I roped my group into at MIT was breaking into buildings. We got really good at breaking into buildings. So before the Flipper Zero came out, we had all of those exploits like on our laptops. And it was kind of crazy. And we're like, we should fix this. And this could clearly be done in the way that we're logging into computers. We just put a little Linux embedded system on the door and actually use OpenSSL to authenticate to the door instead of some protocol called Weekend with some algorithm called hash2 or something. It's like we can use like ECC. This will be fine. So yeah, we went down the hellish path and we built and designed our own hardware. It's extremely slick and cool at this point, but when we're in the middle of building it, I've been far less positive about it. But you can put in a standard wall outlet and like augment any door with it. And then we have an admin portal because our target paying customers are businesses. So businesses actually want to know what's going on. What if I want to get a list of all of my employees' SSH public keys to add them to an authorized key file, or I want it to sync, or I want to know logs of who came in the door. So we built out a whole company around this. And my final slide, second to final slide, on saving the world. So this has kind of been my whole goal with computers. I feel like, as computer scientists, we have a really unique position in society right now that small groups of people can make huge changes. So our Save the World plan is to first secure all the small and mid-sized businesses. So there's this, they call it the security poverty line, where if your company doesn't make enough money to afford a full IT staff, you're kind of under this line where you're just kind of like playing it risky. And you're very likely to get ransomware because you don't have good security. And when you do get ransomware, you're 90% probability of dying. So like that, for me, again, my core belief that I think everyone deserves to be secure on the internet. If you're selling PVC pipe, you shouldn't have to learn cybersecurity. You should just be able to like log into your corporate account and like just go make PVC pipes for the people that need PVC pipes. So that's our first target. There's a lot of moral backing behind that. I think maybe more moral than business backing, but there's clearly a need and we're trying to service that. Then get all the enterprises because they're the ones with everybody's stuff and it'd be great if that didn't get leaked. We do give our product away for free for personal use, so that's secure every human on earth. I have ambitions to get this into e-voting. There's no reason I've seen in all my research that you couldn't vote for the president from your phone on election day. Just get up, cast your vote. It's signed securely with your private key. All the hardware, all the verifications have been done. And maybe we save democracy. And then embedded systems was my core focus in grad school because I just took a Waymo here, and that's a hackable thing. If any of you really wanted a cool, untraceable assassination of me, do it, because I'm going to keep taking Waymos because I don't have to have the awkward conversation. But there's serious vulnerabilities there. So that scares the heck out of me. And this is a little diagram of how this works on embedded systems. I kind of alluded to it earlier. So you would have our code running in the secure world in the trusted execution environment on the phone. You would go to send a command, unencrypted, so developers don't have to know this is happening. You send a command to the firmware to, in this case, I think it says turn on a light, but you're going to twiddle a GPIO pin. It will actually, the assembly code will catch that. It will flip into the secure world. The code that's running in the normal world has no clue anything happened. The processor just freezes. We then generate a cryptographic request. We send it back over the same channel it came in on. The phone then in the secure world shows a prompt to the user. They approve it. It sends it back to all the way through. Then the code magically will continue running. It doesn't even know it ever got frozen. And if that authentication worked, the GPIO pin goes on. And if it didn't, it fails silently to the code. So you truly can secure these Waymos and things like that. If you want to access the brakes, you can guarantee that, or unlock a door, you can guarantee that only a phone with that private key embedded in it could do it. So it is possible. And since I come from the hacking world, you all know the slogan POC or GTFO. So I feel like, demo or GTFO that this stuff works. So I already showed you how to log in and log out of my computer. To show you I'm not bluffing, I will change this to, let's do a biometric to log into my computer. So I'm approving the change of the setting. And now when I lock my phone, I'm going to hit enter, biometric, ta-da. So the other awesomeness, I was planning on showing you this on a Linux computer because it is just better at all of this stuff, but I'll show you on a Mac. So my SSH key, like I said, is on my phone. So this key, and I'll show you in a second, I'll prove to you I'm not lying, is actually on my phone. Only if my phone's connected can you access this SSH private key. Same thing with Git. So if I go to our repos, I can only pull because this phone is nearby with that SSH key. Same with my Git signing key. All of that is on there. My favorite feature, don't know how many developers are here, probably more than one. You can do sudo without a password because the phone is nearby. So your development cycles just go really, really, really fast. And then the proximity login, which is, I think, my favorite feature on earth. Come on, work with me, aerospace. So logging into AWS is probably one of the worst experiences I've ever had as far as logins go. We're going to proximity log into AWS. Let me log out first. So we're an IDP. This is not my ideal scenario. Ideally, we'd be a plugin, so we don't have to go out and become one of those Jenga pieces on the bottom. But that was us logging into AWS. And that only worked because my physical hardware token is here nearby, and I've already said I trust this computer and I trust this browser. So if I would try the same thing from an untrusted session, it's going to take me through the whole usual login process. So I'm going to go log into AWS. It redirects to an IDP, but I don't trust this browser, so it doesn't know my email. Or actually, I'll just use my username. And I have to scan a QR code to make sure that you're not MFA prompt bombing me and all that stuff to set up all the trust relationships. So this is the steps I have made at the Save the World mission that I'm on. GitLab is probably one of my most used ones every day. And now, to prove we're not bluffing, I'll do this quickly because I think the timeout is like 5 seconds. Bluetooth is off. I'll type sudo. you'll see that it failed. I'll do a git pull, it will fail. I'll type in my password so that I can continue showing you things. I will look at my SSH keys, it is not there. And again, if I go to re-log into AWS, all this stuff is gone. So we're getting close. Not saving the world hasn't happened yet, but the technology for it at least exists now.